So today, what we are doing today is Python, basic Python. Basically, Python is a programming language actually. So we use it as a data engineer, as a data scientist, and also as AI engineer. So it's just a programming language actually. So and Python actually supports any kind of operating system, be it Windows, Mac OS, Linux, and so on. So this is just actually showing us how to install Python, like installation in our in our system actually. So and maybe as basically what we actually use today as our notebook today is what we know called VS Code. So we can learn how to actually install VS Code on our various system, maybe via YouTube, watching YouTube video to do that actually, and it's actually straightforward. So what is Python? Python is high level interpreted programming language, as we said, and created by Van Rossum and first released in 1991, actually. So, where is Python used? So, for web development. So, we have for web development, like web applications like Flask, Fast API, Django, for data science and analytics, for artificial AI and machine learning, for auto scripting, game development. It's just a programming language that can be used to actually that can be used in various for various purposes actually. So that's Python. So so let's start with basic Python. Okay, these Pythons. Okay, so let's go to our VS Code. This is actually VS Code. So let me start a um new page. So these are if you download your VS Code, these after installation, these are how it actually looks like. So basically, if you want to start a new notebook, actually, so actually I use a Mac actually, so you might use a Windows, which might actually be different. Don't be deceived by that. So let me just open a new folder. You can actually, I'm just creating a new folder for the Python class. Okay. So Python basically we use the notebook for Python is IPYNB, which means interactive Python notebook. So let's just call this intro.ipynb. So that's our notebook. So we can see here we have code, we have markdown, and we have run all. So now code, for example, this is actually used to run normal Python codes. For example, let's do normal arithmetic, like 1 plus 1. Oh, sorry. 1 plus 1. That's just normal Python because Python can also be used for normal arithmetic, normal calculations and co. Okay. It says I should choose my Python environment. Okay. So you can see two. So Python can also be used for normal calculations also. So for example, let's say print. Don't worry, I will start. I'm just showing you how VS Code works. Hello world. So you can see it's printed. That's our normal code. So here, Markdown. Markdown just serve as heading. Like, okay, maybe you want to write an heading. Like, okay, let's write something like Python class. Python class. We use normal, okay. We use hash to just enlarge the enlarge the what we actually write in our markdown. So we can see now, you can see that's markdown. You know, markdown is just like writing heading or writing a note in our notebook. Why the code is for our code. Okay, that's just normal markdown and codes. So now we have okay, data types in Python. So what are data types? Okay, for example, we have integer, which is called int. Okay, integer is a whole number. Okay, data types entirely. We have primary data type and we have secondary data type. So the primary data type are just like a fundamental building blocks in Python. Just the examples are integer, which is integer, which is whole number like 1, 2, 3, 4, and so on. Why we have float. That's example of primary data type, which is a decimal number. You know, we know decimal number like 3.1, 3.2, and so on. Just a decimal number. That's called float. And we have complex number. Just in mathematics, just a normal complex number. Like, for example, let's say 5 plus, sorry, plus 3j. That's complex number. So those are data types in Python. So these are data types which are numbers, number data type. They are also primary data type. So these are numbers. So for commenting in Python, we use hash and can write this numbers. So these are actually for commenting our codes. So text, we also have text that are primary data type text. So which our example of our text is we have string, which is we in string we can put this and we can write maybe let's write a name Tayo. It can be anything, it can be a cat, but it must have these two quotations actually. It must have these two. Or we can do it like this. Tayo. So what we use for the start, that's what we must use to close it also. If we use the single quotation at first, we must use the second quotation to close it. If we use the double, we must use the double to close it. That's string for us. And we have what we call Boolean, which is true or false or false. Those are the primary data type. And why the secondary data types? We have lists. I just want to how will I put it? I just want to put this first, like so we won't be confused. Like these are the primary data types. So we'll treat this one after the other. After that, we'll go to secondary data type. Let me just tell you example of secondary data type. We have lists, we have tuple, we have dictionary, and we have sets. So those are the data types in Python. So let's move to our normal wherever. So let's treat integer first. Okay. So let me use a markdown here. So int. Sorry, let me put it as integer. Sorry. So integer. So now we said, okay, 23, all number are integer. So to confirm this, There's what we used in type Python. So let's use type. There's what we use a function called type in Python 23 just to confirm the data type for us. So you see it will bring, you can see int. Can you see that's integer? So let's another one type anything that is whole number 100. That's integer. You can see int. You understand that? So floats now. Okay, let me use a markdown again. I think we should know the difference between markdown and quotes now. Floats. So floats, I said it's a decimal number. So let's just put a random decimal number, 100.57. Okay, so know the data type here, just write type 100. Oh, my type is spelling is wrong. Type 100.57. You can write any, you can see floats. So the type is just like a function to know which data type. You understand? So that's floats. So string. Okay, let me use another markdown. String. So string, I told you is the text. So let's say text as what can we choose? Anything. Let's say name, for example. So let's say type name. You can see string. Do we understand? So let's go to Boolean. Okay, let me do another. Oh, sorry, don't mind my spelling actually. It's Boolean, yeah. So let's say true. Type. Oh, sorry. Oh, this will actually work for Boolean, sorry. But I'll actually explain Boolean as we actually have some stuffs we actually treat on Boolean. So that's that. So let's just move to simple arithmetic actually. Let's move to simple arithmetic in Python. Okay, let me call this arithmetic. So simple arithmetic, like we can use Python for our normal arithmetic, like calculations like plus, you can see 2 plus 2, 4. Let's say subtraction, let's say 100 minus, let's say 30. We can see 70. We have division, 5. Let's say 5 divided by 2. We can use our Python for that. We can see it's correct. So, and another thing, we have what we call floor division. Like, okay, let's say something like this, floor division. So, this actually means how many times 2 can go in 5. So Python can be used for our calculations. So let's go to something like, okay, let's go for exponential, like raised to power. We should not all know that. That's exponential. So for exponential, yeah, we use this. We use our this sign star twice. Let's say 2 raised to power 5. So that's 32. And let's do 2 raised to power 2 raised to power minus 5. Raised to power exponential of minus 5. We can see. And also for exponential, we can also use this power POW. So we just write 2 and 5. It will also give us 32. We can see that. And we have what we call modulo. So modulo basically actually gives us the remainder. Maybe when we divide, like okay, let's say 5. Let's say 5 modulo. Modulo is use the percentage sign, modulo 2. So that will actually give us 1, because how many 2 can go in 1? We already know it's 2. Remainder what? 1. It is that remainder. That's what we use called modulo. So that's Python for our normal basic calculation. And also, Python can also understand our basic board mass. For example, let's take a board mass um, um, question. So let's do something like 5. This is just our normal basic mathematics. I'm just showing you Python can actually solve all these calculations. So let's say times what again? Okay, let's say 2. Okay, just a normal board mass problem. 4 divided by 2. You know, board mass, we start with brackets of division, multiplication, addition, and subtraction. So it will solve this for us. We can see that's board mass. So it's Python can actually be used to solve different problems. So this is still basic. So that's Python for us. So let's move to variable. So for example, okay, let me give you an example of what we mean by variable. Sorry, okay. Okay, let's use our markdown. Okay, let me delete this. Okay, let me use markdown here. So I told you I use this hash just to just to enlarge the text. You can see, don't mind my spelling today. Variable. Yeah, okay. So, for example, okay, let's put name is equal to, okay, let's pick a name. Okay, let's say bio, for example. That's a name. So this is a variable, because a variable is what actually houses a data type. So it is a string. So for example, so now, oh, sorry, we want to print name. So, the variable now, we are not actually printing what's actually in the variable now. So we want to print name. You'll see what we to print for us. You can see bio. The variable actually houses the data type. Now we want to print the name. Okay, what is the name? So it tells us bio. We already assigned name as bio. So let's do one more example on this. So let's say x is the variable as 3. So now let's say we want to print x. These are just the basic. If you can understand the basic, you understand the more advanced ones. So we can see. So let's do one. Okay. Let me add more to this. So let's now say x plus 17. So you see it will give us 20. Can you see that? So let's move back to. So I'm just using this note as guideline so we can understand when we're actually reading or doing things ourselves. So we can see here x is equal to 1 and so on. So for example, you see age is equal to 20. We can see 20 is integer. Price is equal to 9.99. Our price is float. True, boolean, and name, just we can see string. It's used just single quotation or column here, or what do they call it? Yeah, and you can use double also. So, but the main problem here is what if you start with a single one, end with single. If you start with double, end with double. So that's that. So we can see Python number, integer is a whole number, float, decimal number, and complex number. It ends with minus j. So this one actually is telling us conversion of conversion of data type. So let's go to that now. Conversion of data type. So let's go back to our VS Code. You can see here it brings the code. So let's say x is equal to which number should we use? Oh, let's say x is equal to 3. X is equal to 3. So let's make it a string. So if you want to make it a string, just add this. Can you see that? So let's make it a string. Let's say y is equal to integer int of x. This conversion. So these are to convert. Let's say this is a string. You want to convert to integer. So that's int of the variable. So let's now say print y. Let's say okay, y print okay y plus 2. So can we see that? And let's call this z is equal to, let's say, float of y. So that's how to convert. We want to convert this x. You know, x y is integer of x. So we want to make um, z float of y. So let's print z. Print. So print, we use print to just bring out results. Print z. So that's that. So let's see. Can we see that? X is 3, string of 3. So we want y is integer of this string. Can we see 3? And we know integer is a whole number. That's 3 plus 2. That's 5. And we said z is float of y. And y is the integer of x. That's 3. So what's the float of 3? 3.0 decimal number. That's type conversion. Oh, sorry. Okay. This is what is typecasting? Typecasting is the converting of one data type to another. So just like what we did earlier in our VS Code. Why is this thing not alert? Wow. Okay. So let's move to Python string. So we know there is also Python string is text. So we can see this. A string is a sequence of character enclosed in single or double quotes. I told you that earlier. If you start with double quotes, you must end with double quotes. If you start with single quotes, you must end with single quotes. So this is concatenation. So concatenation is like combining, joining two joining two data types together. So let's do example of concatenation. Let's go to our back to our VS Code. Actually, I'm just using that VS Code to show you and make you know, okay, these things are, it's not that we just screenshot this without practicing. This is more like an hands-on class. So let's use our Markdown. I told you Markdown is just for maybe editing or you want to write a note. So I use this to just, so let's say concatenation. Concatenation. So that's that. Okay. So concatenation, let's say x is equal to, okay, let's use a string hello, hello, and y equals, let's say, icon. Okay. So concatenation, we use the plus sign to concatenate. Print print x plus, you use this just to create that space there, plus, sorry, y. Can you see that? That's concatenation for us. It's just joining. We have two separate variable, x and y. X is hello and y is Python. Do you understand that? So we want to join these two strings. But the thing is, concatenation can't really work if we actually want to join two different data type. Like maybe you want to join a float and string. No, it won't work that way. So we use x plus, use this normal quotations plus y. So it brings hello Python. So this is let's move to string slicing. So for example, okay. Okay. I want to make this much more easier. Okay. This is 1, 2, 3, 4, 5, 6. Okay. Slicing basically means, okay, if you have words now in Python, like I'm finding a way to explain this to you. So we start, okay, this is 1, 2, 3. Oh, sorry. 1, 2, 3, 4, 5, 6. These are 6 letter words. So this P, we start anything in Python, numbering, like you want to number the words there, or it might even be a list. We actually do this. You understand better in lists, actually, but we are not in list yet. So this is 0, 1, 2, 3, 4, 5. So instead of starting from 1, 2, 3, 4, 5, 6, so we start from 0, 1, 2, 3, 4, 5. Okay, let me just do this for you so you understand. Okay, let's use the same example. Let's use Python. Okay, let's use Python. Okay. So Python is how many letter words? 1, 2, 3, 4, 5, 6. But in Python, we don't count like 1, 2, 3. We start from 0. 0, 1, 2, 3, 4, 5. So let's say the word. Sorry. Let's say the word. Let's make it a string. That makes it better. Make it a string. Okay, these are string here. So okay, so let's say print. Okay, this slicing. So let's say print word. Let's say print word. Okay, it's just this as 0 ratio 4. 0 ratio 4. Okay. So yeah, this is 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. So it is actually bringing. It will actually print what is actually okay. Let's see the result here. We can see the result is pyth. So you notice 0, 1, 2, 3, 4. So it will print from this 0 pyth. You understand? It will print from anything from that 0 to 3. You understand? That's how this works. So let's print. Okay, for example, let's do this again. Print. You understand better in when we do what's it called, lists. Word. Okay, let's say print word. Okay, let's use another example. Ratio. Okay, 2 ratio. So this actually print th. So this is 0, 1, 2. So it starts from this 2 till the end. You understand? So that's how it actually works. That's slicing, just slicing, breaking. So yeah, 0 ratio 4. So it actually brings I told you anything in Python start from instead of 1, 2, 3, we start from 0, 1, 2, 3. So it actually brings anything from the words from 0 to 3. It actually breaks the 4. So but you understand this better when we move to lists. So okay. So this is just common use string method. We have upper to convert to uppercase. We have lower to convert to lowercase. We have capitalize to capitalize our letter. So let's just let's just try one or two example on this. So let's go back to our VS Code. So let's say what is let's say texts, for example. Is let's say Python programming is fun. Okay. So let's make it a string. Let's say Python programming is fun. So that's that. So if you want to make it uppercase, for example, print okay, as a print text dot dot upper. Okay, let me just try. Oh, what's this? Oh, Okay, thank God. Okay, don't mind me. I have a lot of notebook opened. So dot upper. This will actually turn it to back. You can see capital letter. Can we see that? So if it is lower too, we just say low text dot lower. Can we see that? So let's do another example on replace. Okay. Okay, let me continue with this. Print. Let's replace our font with, let's say, powerful. Okay, print text dot replace. We want to replace words here. So let's replace font with, let's say, okay, let's make, okay, this has to be string, sorry. Font, let's replace it with, okay, powerful. I think that's the example in our notes. Powerful. So I think that's that. So we can see it's actually replace fun with powerful. Okay, let's say, okay, let's try it here. Let me just copy and paste this. Let's use Command V. Okay. So this text. Okay, let's say Y is equal to text dot, let's say, upper. Okay, let's try this first. Let's say print Y. Let's see whether this will actually work. Built-in, blah blah blah. Okay. I don't think that will work. Oh, sorry. Don't mind me. Yeah. So let's say print. So any single mistake in Python, you can see. Okay. Any single mistake in Python, there's always an error. Okay. Let's make this, let's replace this. Okay. Let's say print. Okay. Let's say print Y. Print Y dot replace. What are we replacing? On and let's see whether this will work. And powerful. Do you get what I want to do now? I want to change this. I think this should work. It's fun. Okay. So actually, you can join both together, but it has different kind of. This is not working. Yeah, you can actually do both, but anyone can actually come first. Yeah. So what again? Let's try. Okay. Okay, let's go to Boolean. So I told you Boolean is true or false. Look, I think we've done all this. Our basic arithmetic in Python. So let's do something in on Boolean. Okay. So let's do something on Boolean. Let's say A is equal to 16. 16 is a string. So let's say print, let's say print, um, let's say print A greater than 7 and A less than 20. So let's do that. So that's a Boolean. So A is equal to 16. Print A is greater than 7. Yes, A is greater than 7 and less than 20. So you can see true. That's how Boolean works. So Boolean is either true or false. So this comparison operator used to compare values. Please also return true or false. Okay, we have is equal to. When something is equal to, we use double is equal to sign. This is not equal to. That's exclamation and is equal to. Greater than, we all know are greater than. Less than, greater or equal to, and less than or equal to. So let's do something on equal to or not equal to in our VS Code. So let's use x is equal to 3, y is equal to, let's say, 17. So let's make our Python print. Print is just used to bring out results. Print x equals, I told you anything that is equal to, so that will be double equals to y. And yeah, let's say print x not equal to, that's exclamation, equal to y. So you can see false. X is not equal to y when we declare the variable. And x is, okay, we can see this one says x is equal to y, which is false. This is x not equals to y. This is true. So we can see that. So that's operation. That's operator. So let's go to, so this operator continues. These are okay. Assignment operator, we have equals to, we already done that. So these are just, so let's move to lists. So list is example of secondary data type. List is example of secondary data. Primary, we have numbers and text. Example of numbers are integer. So secondary data types, they are actually collections of other data, like collections of the primary data types. You understand? So we have lists, for example. We have lists, we have tuples, we have dictionary, and we have sets. So now we are moving to lists. So we can see these are an example of list here. Okay, let me give you that now. Let's do that in our VS Code. So let's say we have okay, let's say numbers is equal to list actually use square brackets. Just know that. Has nothing to know our list. Square bracket. So let's say we have 10. Well, again, let's say 10, 20, let's say 30 and 40. So these example of lists. So let's know the type. Type, I told you we use that. Type number. Okay, sorry. We use numbers, yeah. So you can see list. Can you see that? So let's call this to fruit. It's equal to square bracket. That's what we used to know. Let's say orange, mango. We have to make it string. Sorry, yeah, text. Don't make that mistake. You can see the good thing about VS Code is telling me whenever there is a mistake, like, oh, check this, oh, there's an error. So that and what's apple? Okay. So type fruits. So you can see list. And we see that that is list for us. Just though lists use square brackets. So a list is a collection of ordered mutable items. Key properties of lists: ordered, mutable, they can be changed. So you can change anything in the list and can store different data types. So those are the advantage. So let's go to okay. Like let's go to slicing in lists. So here, let me use this as example at first. We have these numbers. I don't want to rewrite this. In Python, numbering start from 0. So this 10 is 0. This is 2. This is 1. 20 is 1. 30 is 2. And 30 is 3. So let's just bring it out to confirm that. So print okay, numbers, and let's print 0, for example. You see what it's bring for us. You can see 10. So let's say we want to print numbers in. Okay, let me just rewrite this here. Let me write this here. Yeah. So let me turn this to 1. Numbers start from 1, from 0, sorry, and this is 2. Okay. You can see 0, 10, 20 is 1, and 2 is 30. Can you see that? And we can also count from the back. So let's do this. Counting from the back, which counting from the back actually start from -1. So let's say -1. Where's -1? Okay. We can see to give us 40. Can you see that? Okay, this one says extracting. Okay, list slicing. Okay, we can also do this. Okay, let's do this. Print. Um. Oh, yes. Okay. Let me. Don't let me write. Let me make it faster. Now be number zero ratio. Okay, let's make it 1:2. Ooh, 1:2. So let's see what it will actually bring for us. 1:2 is actually brings 20. It should bring us this is 0, 1, 2, 3. 1:2. It brings 20. So let's say 1:3 now. It will bring out so 0, 1, 2, 3. So it will bring between 1 and 3. So what is actually between 1 and 3? That's 20 and 30. So it won't actually bring these three out. It's just between. That's 1:3. So let's do some other things like let's use this fruit to do append. So think okay. So let's say fruit dot append coconut. Let's say coconut. So okay. Let's say print. Sorry. Okay, let me use this. I want to make an example. Like, okay, let's say, okay, let's use numbers. Numbers. Okay. Okay, these are numbers. So let's say number dot append. Let's say okay 60. Hmm. So this one I actually want to do. Sorry. So you can see I said numbers. These are 10, 20, 30. So append means add. Can you see that? So let me still go with the fruits that I did earlier. Okay, let me just copy this. Let's see. Append means add. So I said fruits dot append. Okay, let's say fine. It's a pineapple. Sorry. Okay, that's that. So we now say print fruit. So can you see that? Hello? Yeah, that's append. So let's say, let's just remove. Maybe we want to remove now. So let me still use this. Instead of append, I will use remove. Just to remove from the list. So I want to remove pineapple from the, oh, okay, let me remove apple. So that's that. So we have different kind, we can sort numbers and so and co. So yeah, this one actually shows length of elements. So we have maximum value, and okay, let's try one. Okay, let's try length. So you can also try all this at home yourself. So let's say length of, let me use the numbers. So you can see length of numbers. We have 1, 2, 3, 4, 5. Can we say because we already append, so we have 5. Can you see that? So let's say max. Another example is max, the maximum value, max of numbers. So you can see what will give us 60 is the maximum number. Can we see that? So if we say sum of numbers, for example, sum of numbers, we can see total sum of everything. So that's that. Sum, it's add all the numbers. So tuple in Python. A tuple is a collection of ordered immutable item. So tuple is ordered. And another thing about tuple is, we said our list is with square bracket. These actually use normal, these are normal brackets. And you cannot change, cannot a tuple can never be changed. You can change in lists, but you can't change in tuple. So let's bring an example of tuple. Okay, let me give you an example here of what tuple actually means. So we say, okay, let's say data is equal to, so let's say this is the major difference here. We use this in tuple. So let's say one, in our list, we use the square bracket. One, two, let's say three, let's say six, let's say seven. So that's data. So let's say type data. So you can see tuple. Can we see that? So that's that. Tuple, the difference between tuple and list is this. Lists use this square bracket. Tuple use these are normal brackets. So that's tuple for us. So tuple two, we can use length, we can do max, we can do mean, we can do sum. Okay, use tuple when data should not change. When you know your data is not changing, you can use tuple. So that's tuple. And we have set. So a set use this curly bracket. So that's a set. Anything that use curly bracket. A set is a collection of another unique items. So key properties of sets: unordered, no index, no duplicate values, mutable, can add or remove, and faster membership testing. So anything that use curly brackets. So let's draw an example. Let's use this here. Let's use this value. Let's say values. Just be mindful, it's just the brackets that actually separate. That's a major difference in these stuffs, in this data type. So values is equal to, we use the curly bracket. So let's say values are 5, 8, 7, 15, 16, 5, 2. So that's that. Let's say print. Okay, type values. You want to know the data type? We can see sets. So if you want to know, if you are confused that, oh, I have the data, I want to know the data type. So just press the type and put in the variable. It will bring out the data type for you. So that's set for you. That's that. And we have dictionary. So dictionary is a secondary data type. So it stores a data in key and value. Okay, key and value in the sense that, okay, let's use this example here. Okay, let's use example here. So it stores data in key and value. Let's say student. Okay, let's use students is equal to. So we use curly brackets also. So in key and value. So key, the student's name. Okay, let's use Ade. Okay. So it stores data in key and value. Just know that. So what was Ade's age? Let's put age. Let's say Ade is 25. You know, he's an integer, so we don't need, let's say, um, course. Let's say Ade is studying data engineering. Let's say put data. Let me put this here. Engineering. So let's normal how to check. Let's say type students. So we can see dictionary. Can we see that? So that shows us the data type. So for example, let's now look. Let's say we want to print. Let's say print students course. Okay, let's use this. See, right, brings it out. So that's S. You can see the student course is data engineering. Can you see that? So it stores data in key and values. So this is the key name, the value of the name. That's Ade. So here too we have pop. So pop course. So we can add remove item. That's it. You actually use pop. There are also other key of words. So that's that. So this. So these conditional statements, if or else. So let's move to if and else statements. So let's start with if. I hope we are enjoying our Python class. So let's say, okay, let's say age, for example. Let's say age is equal to 18. So let us say if age is greater or equals to 18, so print print let's say candidate is eligible to vote. So what's this saying? So these are if statements. Like it's just like a conditional statement. So anything you have if, else, and co, that's a conditional statement. So this is saying we already declared the variable age is 18. So is if age is greater or equals to 18, print candidate is eligible to vote. Can you see that? So let's check. Can you see age candidate is eligible to vote? So let's use else if. Let's add else if. If, sorry. E so let's use if age. So okay. Let's say if age equals to age is less than. Okay, let's use else now. Well, we'll still use another word else. Age is let's say less. Let's use less than 18. So let's say it should print. Let's say print. Okay, let's just don't let me use this example. So we kind of confusing. So we can see this. So let's use if and elif and else. Let me find wherever. Okay, let me find an example. Let's say score. Let me use this score equals. I don't want something that will actually confuse you guys. Equals 80. So let's now say if score if score is greater U score is greater than or equals to 70. Yes, it's 70. Yeah. You say print print excellence. So, and let's use our elif conditioner. Elif score, let's say greater or equals to 60. Let's say 60. Let's say you should print, let's say good. So, and else, if that means if it's not both, that's else you should print. I will explain this for you. Print, let's just call it average. Oh, let's say fail, for example. So what this is actually saying, this conditional statement is saying is the score is 80. If the score is greater or equals to 70, we should print excellent. So elif score is greater or equals to 60, print good. Else, if it is not these two conditions, print fail. So let's see what it will print. Excellent. So let's say the student score 50 now. You should see it to print fail because it's not both. Fail. Can you see? So let's say it's the student score 68. It will print good. Can you see? So instead of writing many if else statements, you can use the match statement. Match is used to compare a value against multiple pattern. It is similar to switch case in other language. So this is another method. So we can use the match instead of our if or else. So you can use case one print, case two print. So this is just another method of using um if or else. If you don't want to use if or else, you can use this. So if you don't want to use, it's still the same. You can use this as to use it as the same condition as if you want to. If you don't want to use if or else statement, so you can use this Python match. So this is loop. We have for loop and we have while loop. So let me show you how for loop actually works. Let's give an example here. VS Code. So let's just say, okay, I, okay, let's say X equals 3. So let's introduce our while loop. Y X, uh, let's say Y less or equals 6. Equals 6. That's a loop for loop. That's I loop print X. So let's say X, let's say plus, okay, let's say plus or equals to, So I will explain this. This is our while loop. So x is equal to 3. X is less or equals 5. So print x. So it prints this. So here, this is our x. This also means x plus 2. That's 5. Let's say this is 1 now. So this is 1. So it's still the same. So yx is less or equals to 6. So it prints 1, 3. Okay. It prints 1 and 3. So that's that. So that's y for us. So it has to be less or else if you make this greater or equals to, so let's say greater, where's greater? Sorry, or equals to. You can see. So it is bringing all numbers that greater or equals to. It is bringing all numbers that equals greater or equals to 6. So let me just delete that. So that's how it works. That's the while loop for us. So this actually, okay, let's see this. I is equal to 1, y I is less or equals to 3. Print I and we do. Else print loop finish. If it is not, print loop finish. So this is I less or equals to 3. So if this condition, if it is not this condition, it should print loop finish. Okay, let's try this. Let's try this. This I, it says I equals 1. Okay. So so it says y, okay, I that's less or equals to 3. Equals to 3. So print I. So print I. So else it should print okay, let me just check what it said we should print. Sorry. I said we should be loop finished. Okay. Okay, let's say end. Let's just call as end just to make it end. Okay. So that no, it shouldn't. So what's the mistake here? Okay, let me use 5. Yeah. I think there should be a breakpoint. Yeah, there should. Let me introduce a breakpoint. Yeah. Yeah, try. Just keep on printing. What's wrong? I don't know what's wrong here. Sorry. So let's continue. You can always try that on your own. So this should actually print loop finished. Actually, this is what I'm actually trying to do, but I don't know what's wrong there. So maybe there's one or two mistakes there. That's Python for you. Yeah. It's might not be one single mistake that is causing all this. Yeah. So let me now say else. Okay. Let's try this. Yeah. Yeah. That's Python for you. Print and yeah, thank you. So we change the statement again. This is what I'm trying to do. So that's Python for you. One single mistake can actually cause a lot. So you just have to be careful. So these for loop. So let's try the for loop. So let's see. Let's use our fruits. Okay, they use fruit here too. So let me just copy and paste our fruit values. Okay. So that actually works. So let's say this fruit. So for loop will now be, this is how we use for loop for fruits, for fruits in, okay, for fruits, okay, it should be fruits. That's a single fruit in fruits. So this is how it works. Print fruits. So this is how a for loop works. So can you see that? It prints our fruits one after the other. So that's how a for loop work. So basically, a for loop we use it most times in Python. So that's for loop for us. So let's go to another. Okay, what's the next? It's almost time. So Python function. So basically, a function is a reusable block of code that performs a specific task. So for example, if you want to declare, like declare a function means, okay, you want to start a specific task. So you use Python function. Basically, in for example, maybe in you want to build an AI system now. So we are now building different agents. You understand? So we want to declare, we use a function to, okay, we want to, maybe for example, we want to use a recommend, okay, we are building an agent that has actually a recommendation tool. It has an SQL tool, and it also has let's say it has we can, okay, let's say it has how will I put it, anomaly detector tool too. So it is three different type of tools actually. So now function work in the sense that maybe we want to start with the recommendation tool now. Okay, to start with that recommendation tool, we declare a function like def recommendation tool. Okay, you want to start with, so okay, we want to go to the anomaly detector tool now. We can say, okay, def anomaly detector tool, just to declare a function to start a code, a kind of reusable block of code that perform a specific task. Normally recommendation tool starts, it's actually used for recommendation. Anomaly detector is used to detect fraud, anomaly, and all that. You understand? So uh, that's how that works. So it's just used to declare a function. So this is just an example. Let's do a quick one here. So it starts with def. So let's say def class. So we are declaring the tax. We are declaring the function class. Def class, let's say print welcome to Python class. Welcome to Python class. So that's that. So don't let me use class. Let me use session. So class means I'm that in the wherever. So that's why it's writing here. Python session. Okay, let's use this. So that's that. So we are calling that session. So that's how it's actually. So that's how it actually works. So let's try an example that actually brings a return that actually returns value. So def, let's say add x and y. That's x and y. So let's use this. Def add x and y. Don't forget this. So we say return because we want a return. I'm just trying to x plus y. So let's say results is equal to add. So let's say x and y is 10 and 33. Let's just say that, and that will be print results. This is just an example. I'm just giving this just to bring just to return something. So we are just declaring if we are declaring a function to start a specific tax. So here we want to start an addition tax. Like you want to add 10 plus 33. So we just put in this. So can you see it brings out 43. So that's how a function works. It's just to declare when you want to start a specific tax. This is a module. So this is just like Python file, extension file. Like, this is our notebook file. So now I can call, okay, let me show you example of py file. Okay, let me go to, okay, sorry. This is one of my codes actually. So you can see this is a py file. I don't use, in a work environment, you don't use IPYMB. IPYMB is just, it's just for you to know, okay, I write this code, I want a result to come out. You understand? So this is just like a Python file. You can see this is an example. You can use it to write multiple lines of codes. Now, I'm not writing to bring out results here. So this is an example of .py file. We can see that this is an example. So if I use .ipymb, that one will be bringing, okay, if I use .ipymb, this is just this line of code alone. It will bring out results for me. But in a work environment, we don't need that. We use py file. So let's go back to our notes. Okay. So that's that. So it's just like Python extension file. So you can see the color of function here. Blah. Okay. So what next? So this is a maths, Python maths. So what's this Python maths saying? So Python provide built-in math function, also include powerful math module. So it's just like you calling Python math function. You can see print power 4 and 3. So this 4 exponential 3, 4 raised to power 3. Like I think we did this earlier, so it brings out 64. It's just normal built-in Python math function. So that's that. So this actually imports math, print math dot square. So let's just do something on this faster. Okay, let's go to our VS Code. So let's go. So this is okay. Let's import math function. Import math. So import maths. Okay, let's say print. Okay, let me put this little space. Make it print. Okay, let's say math dot as SQRT. Yeah, say SQRT. Yes, say okay. Let's say this. Let's say print maths. Okay, instead of rewriting. This is this. Yeah. So okay, let's say so I'll explain this. So yeah, we import math function here. So this is math dot square. So what's the square of one square root of 144? So square root, that's SQRT. So that's 12. So math seal 2.44. So that is seal. This is like rounding up. You understand? So this is rounding up. So we round up to the higher number, like seal it up. So 3. You can see 2.44. So maths.floor, that's to the nearest whole number, like the lower one. So floor 1. So that's that. It's just like our what we've actually done earlier on our math arithmetic function. So this is JSON file. So a format for storing and exchanging data. That's what JSON file is. Text-based, lightweight, and human readable, widely used in APIs, configs, web applications. So JSON file, JSON format is actually used in API. So API basically in some data, you collect some data. Part of if you want to collect data, like data collection, data extraction, you can extract your data through APIs. So what you actually use basically is the JSON format. It's called request. Yeah. So you use AP for API generation to extract data, config, and web application. So this is actually how a JSON this converting if you want to convert from JSON to Python. So this is just like this is just like the query here. This is just an example. So actually for now, I won't really want to touch much on this because it's much more higher than this. So it will naturally confuse you. So this is just normal JSON, JSON dot load to load JSON file. So this is regex. So a pattern matching technique for string used to search, match, or extract or replace text. So that's the function of regex. It's used to search, match, extract, or replace text. So Python uses the built-in regex for module. So regex is RE. So this is an example here. So import RE. So to import regex, anything you in Python, if you want to maybe do import you maybe you want to start something now, you import that function like import RE, import pandas as PD. So as times goes on, we actually talk more on that actually. So you import. So we import regex. So Python will know, okay, we want to make use of regex because regex is in. So if assuming we want to use a function that is not in our Python form, is not in our Python notebook or something like that. We have something we call pip install to install that specific stuff. Like, okay, we want to pip install, let's say, pandas now. So pandas is used for data manipulation and all that. So pip install pandas. So to install pandas. So after installation of, for example, pandas now, if you want to make use of that panda to make Python know, okay, I want to use this panda, so I want to use this particular Python function. No, so you import it. So that's why you say import regex. So Python will know, okay, we want to use regex. So text is equal to my email is blah blah blah. So this is normal find email is equal to re email. So it brings out result that this is our email. So it's nothing much. So we can see pip. So for example, now you can see pip install pandas. We want to install pandas now. So let me show you example of pip install now. So we say pip install pandas. So it's install, you can see it install pandas. You can see requirements already satisfied. Can you see that? So if I want to make use of pandas now, when I say import pandas as PD. So that means I'm telling Python, I've installed these pandas now for data manipulation. So I'm now saying, okay, import these pandas as PD. That Python know I want to use these pandas. So that's that. So if you want to install, you pip install any library. So if you want to make use of it, you import it. So now these are requirement.txt. So requirement.txt is just like, okay, in requirement.txt is just like is a Python extension file that you create that actually houses all the packages you want to use for a particular function. Like all the packages you want to use for a particular task, you store it in requirement.txt. So instead of instead of pip install each requirement one after the other. So now you have pandas, you have numpy, you have Waze spirits. You understand different kind of. You might have sklearn. You might have different kind of libraries. So instead of pip install each library now, you store them in requirement.txt. So what you now do after storing is you now do something like, okay, install from, if you want to install from this requirement, so you now say pip install minus r requirement.txt. That means it will now install all what is inside this requirement.txt for you rather than just pip install one after the other. So that's what that does. So that's that.